Hello and welcome to today's webinar. My name is David Cash. I'm a member of the marketing team here at Mountz, and just want to thank you for joining us today. And hopefully you can find the information that in this presentation will be useful for you and for your applications. Now I'm coming to you from a different location today. I'm here at our Alabama campus where we have our warehouse, our distribution facility, and our calibration and repair labs as well. So a little different look to today's webinar, which is always a good thing. As we look at our topic today of implementing error proofing and process control with smart cordless screwdrivers. So with that, let's go ahead and get started with the presentation. Typically, when we look at implementing processes like this, we want to do basically a process optimization. And what this allows us to do is to be able to compensate for variabilities within the process, help to reduce manufacturing risks, implementing error-proofing strategies, and also to use automation workflows within the process. And when I say automation, I don't mean necessarily a robotic or automatic type of tool that's being used, but automation in the fact that we are removing use steps that typically allow us to be able to move through the process without having to think about things that happen automatically within the actual process. And so if you've been with any of our webinars here, we typically always will mention what the common fastening errors are. Improper torque control is going to be probably the most seen, which we'll have over torquing type of scenarios where you can have a fastener failure because there is too much tension on the fastener itself. It may be close to its yield point, and any type of shock or vibration will cause that fastener to break and fail. If there is an under torque situation, again, any type of vibration will allow that fastener to loosen and then eventually fail. There could be the possibility of missed fasteners within the actual process that's happening that don't necessarily get torqued. Could be a situation where you may have lifted head fasteners where not completely torqued at all. So those are a number of fastening errors that can occur. And a lot of those types of errors are going to be human errors that are possibly given the ability to remove some of those factors by using smart tools like we're looking at today. The other types of failure could be a tool itself may be out of calibration. It may have moved out of the range that it's dealing with. But again, those are kind of the typical fastening errors that we will see within many assemblies. So that's going to lead us today to our poll question, and that is going to be how frequently are you experiencing fastening failures in your manufacturing process? And so the choices are daily, weekly, monthly, quarterly, or too often for your liking. And so I'll give you just a minute to respond to that. And when that is complete, we'll go ahead and move on with the presentation. All right, that is giving us a tie between monthly and too often. And so I imagine that too often is going to be a result, even if it is monthly or weekly, what that type of issue is when you're having fastener failures. So when one way that we can kind of combat the fastening failures is by implementing an error proofing strategy within the actual rundown. And with that, we can use tools like we're talking about here today. Again, a smart tool that allows us to be able to look at more than one type of factor to ensure that the fastening was done correctly. Oftentimes when you're dealing with one style of a specific tool, it's just going to look for a torque value, and that's it. And so once the torque is achieved, the tool will shut off, whether that is a clutch tool, a pneumatic tool, electric torque screwdriver, that type of tool, where it's going to run to a certain torque value and then shut off. Now, we can help to prevent some of the fastening errors that we might see by also looking for the amount of turn that happens within a particular fastener. We'll refer to that as angle or degrees of rotation. That may be something else that will be heard, but as the fastener is rotated during the assembly process, however many degrees of turn that happens, that would be the angle that's being used. And so in this case, we've got 2 revolutions within our fastener. So that's 720 degrees of rotation. Now with the tools, we do have the ability to create what is going to be an acceptable window for that movement. And that can be whatever might be helpful for that particular application. But we can have a minimum value and a maximum value. And not only must the torque be met at that particular value, but we also must meet the amount of angle or turn for that to be considered a good fastening rundown. And this helps us to be able to detect any type of cross-threading type of error, because a cross-threading error is going to happen right at the very beginning of the rundown. It's going to immediately run and hit torque, but we won't have enough of the minimum angle requirements to have been met. So we would receive an error that it torqued before the minimum amount of turn happened. With the maximum amount of turn, this is going to help us to detect if there is any type of stripping to that fastener. So if that goes past the maximum amount of turn, then we would receive another error there. So again, we're basically looking at 2 separate types of validations for the torque and the angle for that particular fastener for it to be considered a good rundown within that scenario. And at that point, then that would be counted within the process, and it will allow us to move on through the actual application. So when should we consider about using some of the workflow automations? Typically, we want to be able to do that when there are going to be a number of fasteners that are going to be in a repeating format on many stations, where we may be able to consolidate those into being able to use a smart tool that gives us the ability to have different presets available to us throughout the range of that particular tool. And then this gives us the ability to have basically a number of different tools within the process at one location, instead of having a number of different tools across different stations that would be doing a similar or repetitive type of application, but within the use of one tool instead of many different styles of tools. We can also look at it when we want to make sure that we're ensuring a torque control within the process. So we can gather those different types of variables that we can look at to make sure that not only is the torque being met, but the angle is being met. And there's some other ways that we can do that as well. With our process control, we want to make sure that all of the scenarios within a particular application build are accounted for, and we're using that. If we want to be able to gather data in real time, we can be able to get that information from the tools and the controller to make sure that it's falling within certain parameters or other types of sets of data that we might be looking at. So we can pull that information in real time. And we can also integrate the system with different line control devices, whether it be a PLC or a light tree or some pneumatic locks, something that's going to be holding a particular jig. Those types of devices we can communicate with that to make sure that that's part of our workflow designed for our actual process. And so when we look at the smart cordless screwdriver, our EPT series of tools, we basically have two configurations of tools. There's the pistol grip style tool, and then also the right angle style tool. And we can go in range from about less than 8 inch pounds all the way up to 450 inch pounds with those particular variations of models within those particular styles. So each of these tools does have the ability to have 15 different torque presets. We have the ability to include the error-proofing system, where we can look at not only the torque, but then we can also monitor the amount of angle that happens. There is the ability to use what's called a multi-step process, where we can use different presets that would be incorporated into one trigger pull or one application event, where we can take a fastener. It could be in a really type of soft gaskety type of joint where we want to exercise that joint. So we could run the fastener in at one preset, pull it back out, run it back down at another preset, pull it back out, and then run it to a final preset. And that can all happen with one trigger pull event. That's going to be our multi-sequence process. And then we also have the ability to create an actual assembly process. And this is what we're going to be taking a closer look at with the demo portion of today's presentation, where we actually have multiple tools that are being used in in our case, a very simple type of application, but it can be used to create an entire assembly process to help guide the operator through the process, where it's managing all of the different presets that might be used, which tool needs to be used, and it won't advance through the actual application unless we get a good rundown from the system. So that's kind of a little bit about these tools. These are transducerized tools, meaning that it's capturing the torque data as it's as it's happening within the actual assembly. And so these work in conjunction with a controller, and we'll look at that here in just a second. But we often get the question, can the tools be used standalone without the controller? And the answer is yes, they can. You do lose the process control component of the assembly, but the tools themselves will function primarily every bit as the same as they would with use of the controller. You still have the ability to have 15 different presets. You can program the tools to use those different presets. They just need to be changed manually by the operator. And if you do want to record the data from those fasteners, the information has to be pulled off of the tool during a periodic time when you're connected to the tool with use of the software. So again, the tools can be used standalone, or they can be used in what we'll show you today with use of the actual controller. So looking at the tool itself and what the display looks like, this gives you kind of an idea of what is happening with that. So up here in the upper left is going to be your Wi-Fi signal strength between the tool and the controller. And typically this connection is going to be about 30 meters or so. is the distance that you can be away from the controller for it still to be able to communicate with that. So it's quite a large distance that it can be used in. Over here is going to show you the amount of battery that is left for the tool's battery. The batteries are designed to be or allow the tool to operate in a typical type of shift environment. Each tool is shipped with 2 batteries. So if there is a chance that you're using maybe the tool closer to the higher end, it may be drawing more power, you would have another battery that is there ready to go. And the smart charger that is available with the system can take a fully depleted battery and charge it to a full battery within about 50 minutes. So 50 minutes. And so less than 1 hour. And that battery will be charged at full strength here. So below that, you have which preset is being used. So right now it's currently on preset number 2. What the target torque is for that particular preset. You have what is showing the last running torque value along with the unit of measurement. And then down below that, you have what would be the amount of angle or turn that took place in that last rundown. And then you have another set, a 4-set menu here that are work in conjunction with the soft keys down here. So F1 through F4 are going to correspond with the mode, the display, and the up or down arrow within that. And so if we want to change a preset, we want to move up in that, we can simply just hit the up arrow and it's going to allow us to go through the different presets. If we hit the down arrow, again, we can go through and do that. So we can use that and change that manually, as I mentioned a little bit earlier. And so on the tool itself as well is a status light that is flashing on the top. And when that light is flashing, that means that that tool is disabled. And so when we're dealing with multiple tools in the scenario that we're going to show you, only one tool will be able to be working at one time. And that particular tool is the light, the status that is a solid color and not blinking. Again, just to make sure that the right tool is being used for the right application. So if we take a look at our what our process is going to be for the controller, this kind of gives us a little bit of or kind of a walkthrough of what's happening with the controller itself. So it's a 10-inch touchscreen display. We've got a micro SD card slot on one side. There are 2 USB 2.0 ports, an Ethernet port, and then also an HDMI out port. So if we want to mirror this display to another monitor, we can do that as well. There are also on the lower portion of the controller are the IO ports. So there's a 25-pin IO. We also have the RS-232 port and the power supply port there as well. And there's one additional USB port on the top of the controller as well. And then there are Versa mount controllers or patterns on the back of it to be able to monitor or mount that wherever you might like. And so if we take a look at what our particular scenario is in our particular application within the process control type of environment, we're going to be assembling a brushless DC motor where we're going to be attaching the housing and then we'll be attaching the cover. Now, I don't physically have the motor with me, but it's going to be represented on the screen of the controller. And then we're going to be using what are known as angle steps within or angle fastenings within the process, just to kind of show you what that means within the process. But when you're looking at different fastening strategies that you can use with the DC tools, we can either set those to be a torque control where we're setting the tool to a specific torque, or we can use what would be our angle control, where we're going to turn that fastener to a certain degree of angle. So that's what I have set up for these different presets that we'll be using. Our basic angle steps or angle fastening strategies that will allow us to move through the process for the demonstration to make it a little bit easier to see and understand. So with that, our actual application again is going to be a 2-pass housing on the motor here for those housing bolts, and then we'll do 3 on the cover for the or 3 fasteners on the cover. So let's go ahead and we can jump in to take a look at the actual controller here and what I have. And so first, what you'll see in the upper left here is going to be the number of tools that I have connected to the this particular controller. Now it's showing that we have 2 of the 5 tools that are registered to this controller are available to be used right now. And up in the middle here, you can see I've got no tool selected. If I want to go in and change any type of parameter or preset for a specific tool, I can simply swipe down on the screen here. It's going to give me access to be able to use one of those particular tools to come in and go ahead and change some of the parameters that might be within the tool itself. But we do see these 2 tools are being used. In the upper right, we have our time date stamp that is being used. So every particular reading that we are taking is being time date stamped, where we're capturing all of the data information that goes along with a particular type of application or rundown. And all of that information gets stored either locally on the system, or it can be exported out through the use of the I/O ports or through the Ethernet as well. And so in our case, we're going to be looking at a particular application, as I mentioned. So in our job manager here, you can see we've got a number of different jobs that are already in here. We can create up to 256 different jobs, and each job can have 256 different steps. All of those steps within it are either going to be a fastening step, a delay step, or an input or output step. And that may look a little bit clearer as we look at the actual makeup of the application. But if we go into our operation mode here, and we want to be able to select the particular job that we want to do, we can do that a number of different ways. We can come in and we can select from the list of different jobs that are available. We can also use a barcode scanner to be able to select a particular job. And so in each tool, it is equipped with a barcode scanner built into it. So for this particular job that we have set up, I can just scan a particular barcode, and it's going to go ahead and pull up that particular job. In this case, this particular assembly that we're working on here today with our DC motor. And so now at this point, the instructions are telling us that we need to scan the product barcode. And within this step, basically what we're doing is that we can include the product ID or barcode within the actual data stream that is being collected. And so if I scan the barcode for this particular motor, I'm just going to be using this particular barcode here, but I can scan that, and now that becomes part of the data field and data stream that we will be dealing with for the assembly. And so now all of the readings that we will be taking for this particular assembly will be linked to that specific barcode, and that will be a searchable data point within the data that is sent out. And so right now, the controller is alerting us to the location that we need to go to do our rundown. And so if I use the pistol grip tool as we were prompted, I go ahead and run that down. If we get a good signal back from the tool, it will go ahead and then index to our next location. And we can then go ahead and run that one. And again, it's moving us through the process here. And you can see on the tool here that we are on preset number 1 there. And if we did get an error with the fastening, you can see it turns the target red, and then it prompts the user to go ahead and retighten that one. Once we get a good signal, it will go ahead and index to the next location. And so now we're doing our second pass here, and then the tool has automatically been switched to preset number 2. And we can go ahead and tighten those fasteners. And once we finish with our fourth one, it's then going to prompt us to go ahead and use our pistol grip tool. And we're going to be using preset 3 on it. And we can go ahead and tighten those down. And it is now changing the orientation where we need to go, and then finally to the top. And once we complete that, we get a job okay signal, and then the system will go ahead and reset. We can have this automatically set to go ahead and start this particular job over again, or we can put in a prompt that would allow the user to scan another barcode, and then it would pull up that particular job as well. And so in creating this particular assembly, we can see here, this is these are the basic steps that we are dealing with. So we have a message step, our scan a barcode. So it's waiting for us to scan this particular barcode. But that barcode could be set to anything. We have our delay here. And if we run through the system again, this basically is just the graphic representation of the actual images that we were looking at. If we want to go back to the images, we can do that here, and we can run through the assembly. And we get the job okay signal again. And so if we go back to our main menu here, this is after you've logged into the system. For us to be able to take a look at how this is actually built, let's come in and we can edit this particular process. And so we have our message steps, our delay, and our fastening. But let's say we wanted to change the order of the actual rundowns locations for those particular fasteners. So in here on this fastening set, we've got the tool that we're using, the number of fasteners. We have 4, and then we're using preset number 1. And so if we tap on the image itself, you can see that we've got our 4 different targets, but we need to switch number 2, number 4, and number 1 and number 3. So in this case, we're dealing with preset number 1, or excuse me, fastener number 1. We can just simply drag that to the location that we want, index this here, and go to preset 3 and move that here. And then if we need to fine tune the location, we can use these arrows and go to fastener 4. And now we've changed the actual target information for that. If there was items on this side of the image, we can just flip the menu over there. We can also move the menu all the way off the screen. We can bring that back up or move it back there. If we want to change the color of the targets, that's done right here. So we can just change that, and we've changed the color of a specific target for that particular application. So it makes it very easy to go in and build applications, edit those applications, and then go ahead and deploy those applications for use out on the assembly floor. And so with that, that will kind of bring us to our questions and answers. And so Vinka is handling those for us today. And so Vinka, do we have any questions?
Yeah, Dave, we have a few questions. The first one is, how many fastening events or presets can be programmed with each tool?
So each tool has the ability to have 15 different presets that can be used throughout the range of the tool. Those presets can be, again, either a torque strategy, or they could be a turn or angle strategy. And then we also have the two multi-sequence processes that can be used, multi-sequence A and multi-sequence B. And those can be made up of the 15 different presets that are available. So in total, it could be 17, but typically there are 15 presets that can be used with the tools themselves.
Awesome. The next question is the data from each rundown stored on both the cordless screwdriver and the EPC10 controller?
So the data, if the tools are connected to a controller, the data is going to be sent to that controller. The data then can either be collected there on the controller. There's internal memory. There's also the SD card slot, the micro SD slot that can store the data there as well. So when it's connected, when the tool is connected to the controller, it will capture that data. Again, either store it, or it can be sent out through the Ethernet port or the IO port. If the tool is not connected to the controller, then the data is going to actually be stored on the tool itself. And it can store up to like 75,000 readings or so. But then once that tool is connected to the software, it will go ahead and can download those readings from the tool. So the answer is it's on both, but just depends on the scenario of the tools that are being used.
Awesome. All right, one more question. Does the cordless tool use a clutch system, or is it controlled by another method for torque control?
So these particular tools are DC tools, meaning that they are using a transducer in them that is monitoring the torque. And once the tool reaches that particular torque value, the tool then is stopped. And that's being controlled by the transducer that's in that. So it's not like a standard clutch tool or a pulse tool or a cam style tool or something like that that's being controlled mechanically. It's being controlled electronically.
All right, awesome. And we have a couple more questions. One person is asking, we use our tool away from the controller. If there is a fastening error, such as incorrect angle, is there an error indication from the tool itself?
Yes, the tool will stop and pause, and that amount of time can be programmed. But yes, the error will show on both the tool and the controller. If the tool is not connected to the controller, if there's some type of communication error, it will error in that preset as well. And once communication is established, again, it sends those readings to the controller. So,
all right, and then another one was, do the tools have range, or is every tool the same?
Yeah, every tool has a different torque range. Dealing with it based off of what particular values may be needed. So you can certainly see those ranges on our website. If you go into on mountz.torque.com. Obviously, go to the EPT tools. You'll be able to see all of the different ranges within each model.
Awesome. Thanks, Dave.
All right. And with that, thank you very much for joining us today. I hope you found the information here, something that you can use in the future. And we'll see you next year. So have a good holiday season, and we'll see you next time.